Hi and welcome to the Neil Ashton podcast. In each episode, we explain some of the fascinating ways that science and engineering are changing the world around us. We talk to leading engineers from elite level sports like cycling and Formula One, to some of the world's top academics to understand how fluid dynamics, machine learning, supercomputing are bringing in a new era of discovery. We also hear some of their life stories, their career advice, and lessons they've learned on the way that I hope will be helpful to you too. So sit back and enjoy this episode. Welcome back to the Neil Ashton podcast. Today's episode is with Chris Rumsey, who is a research scientist at NASA Langley Research Center. This is another one of these episodes that is going to get quite focused into computational fluid dynamics and turbulence modeling. So I'm hoping if you're interested in that, then this is great for you, and diving into a topic and speaking to somebody who I think is has played a key role in this industry and this community. But just a caveat that if you are maybe outside of CFD and you've been watching or listening to some of the episodes on Formula One or cycling, just be prepared. This does get quite deep. So I just put that as a warning out there. A quick thing as well, I should say, if you're listening to this podcast, there is also a YouTube version where we have the full video. You just type Neil Ashton podcast. But equally, if you're watching this on YouTube right now, and actually sometimes you prefer just to listen to a podcast, it's also available on Spotify and Apple. And thanks to those who have already listened in. I can't believe there's over now 15,000 subscribers on YouTube, which... yeah, I thought it'd be, 5 people and a few of their mates. So I'm pleased that at least some people are finding this interested. But yeah, so if you do like this, I hate saying this thing, but I'm told I should say it, the whole like and subscribe, just because then if a new episode comes out, you know about it. So today's thing is, like I said, about Chris Rumsey from NASA. I have to say that I have a personal... I really like Chris as an individual, and I hope many other people who know him will agree with me, and after watching this you'll also agree if you didn't know him before, because he's just such a nice guy. He's just such a pleasure to talk to. He has no ego, he's very modest, but he has so much awareness, and we discussed many of the things that he's done. He's created and shared so much. His role as sort of public dissemination, the papers he's written, the websites he looked after, the workshop he's done, so many of these things that I genuinely think have had a huge impact on every person out there who develops a method, a code. And this is particularly true in the aeronautical sphere and things like drag prediction or high lift prediction of aircraft. Chris has really played a huge role. But some of the things that I found interesting and that we get into is I didn't know Chris was an artist, so we talk a little bit about some of his early passions for that. How that he actually interviewed for the CIA. Again, I had no clue about that. But I guess the conversation is split into two. The first half is a little bit about his career, how he got into CFD, some of the early days at Langley. Talking a little bit about the turbulence modeling website that he was one of the founders for, and if you look in the caption notes or the show notes, there's a link to that website if you're not aware. It basically lists almost every single turbulence model that CFD has, so that you can implement it and you can verify that you've implemented it correctly, and then you can validate it against some test cases. This is widely used, as he said, as more than 40,000 visitors a month, because it is one of the central places for these models. And that's not just low speed aerodynamics. Almost anybody who's doing any turbulence modeling quite often goes to this website to find the formulation and the papers. And if you're writing a new code, hundreds or thousands of papers reference this site to verify that they've implemented the model correctly. So we talk about some of the origins of that. We talk about the High Lift Prediction Workshop, which is a workshop that is trying to advance the state of the art for high lift aerodynamics. Again, I'll put a link in the chat. And we talk about how some of those came about, some of his thoughts on the role of machine learning for CFD and for turbulence modeling. Again, something that he's been part of arranging with other symposiums and workshops to try and explore this place. We also get into some discussion of certification by analysis and some of the challenges of machine learning applied to that, how reproducibility, etc. And then we shift a little bit, because one of the things I wanted people listening to this to get a feel of is what is it like to work at NASA? What was that journey like? I'm always jealous of people who work for NASA. It was a dream of mine to work for NASA, and even though I did spend a little bit of time there, I was never a civil servant like Chris is. So we dive a little bit into how he got in, how other people, the differences in the roles, and then maybe a few more light-hearted things around some of the conferences the most memorable times he's had at conferences and events that he's done, and then a little bit of discussion at the end around whether it's best to pursue your hobby as a job or do your job and have a hobby afterwards. So hopefully an interesting explanation or exploration of someone who I think has made a really key role for CFD, and just someone, like I said, is just such a lovely and nice individual that I hope if you haven't met him, that you have the opportunity to meet him, because he's just a pleasure to speak to. So yeah, please sit back and enjoy this episode with Chris Rumsey. I think most people have a dream, or at least I did, of working for NASA. It's sort of like when you're growing up, there's this certain thing. It doesn't almost matter what country you grow up in. You think about NASA. You actually do work for NASA. Yeah. So yeah. Did you always actually want to work for NASA? Was that sort of a childhood dream?
No, not really. When I was in college at Rensselaer Polytechnic Institute, RPI, they just had interviews, and I actually interviewed for the CIA, and then I interviewed for NASA. And it just struck me at the time that it would be a good place to work, and it sounded cool then. But I hadn't thought of it before that time. Just that they had an opening, and it sounded really interesting.
Oh, okay. I need to back up there, because I wasn't expecting that answer. Is that because of where you were living? I mean, was this when you said the CIA or NASA? They're quite different things. Were these graduate programs essentially, or?
No, it was just at the time they just had the school had job fairs, and it was just random companies would come in, from all over, and you just signed up for the ones that you were potentially interested in, and just had. It was almost like practice interviews where you could talk and not worry so much about it, because you were just kind of trying to get a feel for what was out there, and I just remember those too.
Did you ever think what would happen if you'd have gone down the other route? I guess
I'd be a spy, I think.
Yeah. Well, we wouldn't be having this conversation, that's for sure.
That's right. Yeah.
But hold on. So what did you study then in university?
I went into aeronautical engineering. So I started. Okay. I went directly into the aeronautical engineering program, and so I was always interested in aeronautics and aeronautical engineering and mathematics, that type of thing. But the aero appealed to me, I guess, because of airplanes and space. I've always just found them fascinating, that they even work. So, when I was a kid, it was like, wow, look at that thing. How's that even working? So just always fascinated me and interested me. So just wanted to get into that field.
And were you the sort of child who was very obsessed with planes and fighter jets and all that, or were you more just
not really. Actually, I was more into art and artistic things. I was, in fact, I almost went that direction instead of engineering, because I was good at art, good at drawing and painting and things like that. But teachers convinced me that it would be better to go into something more lucrative and where you have a definite type of income, and then keep the art for a hobby or something to do on the side, or to do when you retire type of thing. But that's also partly why I was interested in aeronautics, is because of the sleekness of the airplanes and how they were shaped, and the design aspect of it was fascinating to me.
Interesting. So I see behind you, are these some of your works that you have?
That one, those are mine. Yeah. Mm-hmm.
But see, you said before we started, I've got nothing interesting. This is something I did not know at all. Okay, that's interesting. So you were always, were you tempted to go into architecture then at all, that side? Or was it more the drawing, like art, proper art?
Yeah, maybe a little bit, the architecture. It doesn't move though. So maybe it wasn't quite as interesting from that perspective. And actually, when I was at RPI, they had an architecture program, and one of my roommates was in that, and he was just miserable. It was awful because the mathematics part of it, was always very definite. You're either right or you're wrong. But the art part of it is very subjective. And if you happen to have a teacher who just doesn't like you for some reason, he can just say, I don't like that because it's not good. And it's very subjective. So he was driven crazy by that.
So you did your undergraduate, but then you went on to do a PhD. Is that correct?
Yeah, at RPI, I stayed at RPI for the undergraduate and a master's. Did those kind of together. Yeah. So it went fairly quickly, and then came to NASA, and then I got my PhD through NASA. NASA has a nice program where they will pay for you to get your degree, because it benefits them to have someone who's smarter working for them.
Oh, okay. Yeah, so what did you do your PhD in then? What was the...
It was in aeronautical or aerospace engineering. It was at the University of Michigan, and it was numerical methods under Bram van Leer. And that was he was my advisor.
Okay. And
that connection came about because of NASA, because at NASA we had the iCase program. I don't know if you've heard of that, but it was a really nice institute, kind of like there are other institutes like this elsewhere. ICAS, what does it stand for? I don't remember what it even stands for. It's not around anymore, but it was a small institute that was independently run within NASA, and it was actually housed in the building where my branch was located. And it would bring in, mostly in the summers, all these professors from all over the world, Bram van Leer, Phil Rowe, all these really great CFD guys, and Turbulence folks as well, to come and work for the summer or other times. And they would also bring in young undergraduates and build up the science that way. And so being housed with them, we got to know all these folks, and it was really a great relationship. And because of that is why I then worked for Bram for the PhD.
Okay. But did you always want to go into the more CFD side rather than wind tunnel testing? Was there a reason for going in, or was it just that was a choice of PhD that was available?
Well, the branch that I joined this was the time when CFD was kind of getting started. So it was a new branch that had just gotten underway maybe a year or two previous. And I was hired into that branch, despite knowing very little about numerical methods from my undergraduate and master's work. I didn't do that much with computer science, but the branch was all numerical methods. In fact, when I first got there, one of the first things they do is they sit you down, and each person in the branch who was already there would talk to you about what they did. And I just remember sitting there going, what the heck? I didn't know what a vortex was. They were just talking like gibberish. So I was brought in and really trained on the job to do the numerical methods.
Wow. So what was the state? This is NASA Langley.
It was NASA Langley, yeah.
And so what was it like at that stage? Was there any major projects going on at that time? The space shuttle, am I getting the dates wrong now? When would that have been?
I'm sure that was going on, but we weren't at least to my knowledge, that involved in that. It was more fundamental development of CFD codes for doing analyzing wings. Starting out with Euler and then moving fairly quickly after I got there into the Navier-Stokes and started up these codes. I don't know if you remember any of the names of the codes. CFL 3D and TLNS 3D. They were very old codes that were. And worked with, Tony Jameson was somewhat involved too, or he was in the same cadre of folks that came to iCase. And so everyone was working on the same, in the same area trying to build up the CFD methods.
When did you start to transition more into turbulence modeling compared to pure numerical methods? Was there a sort of turning point when that happened, or a particular project?
Yeah, it was kind of a gradual shift toward that. Part of it was that we had some turbulence, the turbulence work was going on at iCase, and then we had some folks in the branch who were more turbulence modelers, and I just started to work with them a little over time. And of course, our codes, starting out with just Lambda and Navier-Stokes, but then we needed turbulence models, so we put in the Sabisi-Smith and the Baldwin-Lomax. And then, of course, in the early 90s, Philippe Spallart and Florian Mentor, who you've interviewed already here, their models came out, and we worked with them to put them in our codes as well. And then it just kind of built from there.
Yeah, I was trying to, when I was asking Florian about that, what was it like at that time? Because looking back, it seems like that must have been this really, fast-paced development, all these models. Did it feel like that, or at the time did it not? Do you know what I mean? Did it feel like you were onto something momentous with these new models coming in that gave better accuracy than before, or did it just feel like a normal part?
No, I don't think it felt normal. It was. I think we saw it as major developments. I mean, because the ones we were working with before were just I don't know, so touchy and I don't know what the word is, but.
Ad hoc.
Ad hoc, yeah. And then to have these, actually, even before Philippe Spallart's model, there was the Johnson-King model, and that one, I spent a lot of time working with Dennis Johnson at NASA Ames to put that in our code. And that was a very difficult model to implement, I'd say. In fact, if we had to do verification on that model now, I think most codes would all be giving different answers, because it was searching along lines to find things. I don't know. It's just not very easy. And in fact, there was kind of a funny story with that. We had two codes in our branch, CFL 3D and Fun 3D, and we started comparing against each other. And at one point, we were getting different answers with that model. And the TLNS 3D answers were better compared to certain experiments when we were comparing. But it turned out that there was a factor of 2 error in their coding. So putting in that factor of 2 just happened to give a better answer. This is a story of turbulence modeling, right?
Yeah. There's always a 2 missing or a half missing.
Yeah.
Okay. Just so for people to understand, so CFL 3D, am I correct? That was the structured focused code, is that right?
Well, both TLNS 3D and CFL 3D were both structured codes. Yeah, they just kind of developed side by side. Within the same branch. And then Fun 3D came along. This is also within our branch. Came along. The unstructured code came along around that time, started to build up.
Okay, so were you quite involved with Fun 3D as well, or was it more CFL 3D?
It was more, for me it was more CFL 3D. The Fun 3D I wasn't too involved in until later. Yeah, maybe in the 2000s I started to get more involved on that team.
Now, one of the things that I was really interested to know, the turbulence modeling website has become almost everybody who's developing turbulence models or not even developing them, testing them, verifying them, validating them, sort of you go to that website now. But how did it all begin? How did that even start?
Yeah, that during the early 2000s, I guess, Brian Smith from Lockheed Martin and George Huang from where is he now? Ohio State, one of the universities up there. we got together and we were talking about this, how it would be nice to have a website or a place where people could go to see how models behave for basic problems, right? That was the first idea, was to say, okay, well, if I want to run a case that's really dominated by, shear or a jet, an axisymmetric, different type. If I have this dominant basic problem, what is the best model for it? And to have a place where people could just go and look it up and say, like a little library, say, oh, for this type of flow, this is the best model. Or whatever, or this is the flaws of the model here. And so we created this team, the Turbulence Model Benchmark Working Group, which still exists today and still meets fairly regularly, to get together and talk about these things and maybe start to formulate plans for that. So that's really where it started. And there were some special sessions at early AAA meetings where we brought up the ideas and talked to people about it. But then the part of the website, the verification part, which I think has maybe had a little bit more impact now, that was actually something that I came up with as a total fluke result of what I would call serendipity. Just something that just happened at a workshop I went to, and it was something in it was a workshop in Europe. They used to have these. I can't remember the names of the workshops, but they would get together kind of like they do now, and everyone would run their codes with certain models.
Was this a COFTAC, maybe?
It was an COFTAC. Yeah, it was an COFTAC. Yeah, sponsored event. And then they would compare results. And usually it was something with separation because no one could do that. And then they would draw conclusions from them, or not, which is maybe more often what happened. And at this workshop, at one point, they were showing results, and I was using CFL 3D with a Spilart-Almaris model, and it turns out that another group, I think it was Honora, was using, I believe it was ELSA, but one of their codes, using the same model, and there were all these results, but these two results were right dead on top of each other, and it was these two code results, and I realized then that this is a good way to determine whether you've coded it correctly. If two people, because it's so much more likely that if you get the same answer, what are the chances of a coding error if two are absolutely dead on top of each other like that? And so it just struck me that was a way of doing a kind of cheap verification, without the formal method of manufactured solutions or other methodology, but just the more code you compare and the more the degree, the more confidence you have in that this is right.
And do you have any stats on that? Do you know how many people actually go to that website? Have you ever done any?
Yeah, I mean, it's hard to say because they have these, Google has a way of tracking these things, but I don't know what these numbers actually mean because I don't know whether it's actually people going to it or robots going to it. I don't know what it means. But yeah, it's quite a bit. I can't remember, maybe 40,000 a month or something like that at the most. Yeah,
it's a lot. I'm sure it is because everybody seems to go there. It's it is a credit that Brian, yourself, and the rest still keep this going because I used it in my PhD. I think most people do it. It's such a But I always feel bad for you because it seems like your website coding skills quite good now because you always seem to be updating websites.
Oh yeah, that has happened. And then one unintended consequence of the website too was just, I didn't realize this at the time, but having one place just to go for information like that is really, I do it all the time myself. Like instead of having to say, okay, well, I got to look up this thing brought this model. So you have to find the paper and you have to remember where the paper was. You have to remember which year it was published. And this way it's just, it takes you 10 seconds and you're there.
One of the things that stood out in that 2030 report was the lack of machine learning. It's kind of incredible in a way. If I'm not mistaken, there was very little mention, if at all, about machine learning. And fast forward to now, and is that, where do you I mean, this is a big topic, but so let's say, first of all, for turbulence modeling, where do you see the role of machine learning? Are you positive about? Are you thinking there's overhype in this area around turbulence modeling to begin with?
Yeah, I think there's a little bit of overhype, and it's coming back down to ground now a little bit, because I think at the time, well, first of all, I think when the 2014 report came out, there wasn't much machine learning out there. I mean, it was there, but not so much in our field. So it wasn't even in the authors' brains at that point. But I think then that the thought, there was a lot of thought that, oh, well, this is going to answer everything. Within a few years, we'll have all the answers. And that did not pan out. And now I think maybe the thinking more is that machine learning, in conjunction with someone who understands turbulence, like a turbulence model developer, somehow working hand in hand, it may be like another tool that could be used to help the turbulence modeler develop something. But that the machine learning itself it's not going to do it on its own.
So yeah, we were talking before about the high lift. So where did, I guess similar to the turbulence modeling website, high lift workshop, among some of the other workshop, has, I would say, been responsible for pushing a lot of the innovation, particularly around scale resolving methods. I think in the past few years, there's been a lot of advances in that. But where did that actually start, the high lift workshop? Do you remember the origins?
Well, I mean, I guess the drag prediction workshop came first and became the source for a lot of ideas for workshops subsequently. But the high lift workshop was, I guess it was the brainchild of the NASA collaboration with folks at Boeing and other of the commercial companies, that where high lift was the solution, or the need to solve high lift accurately with CFD. It was seen as a major stumbling block, and it's, still is today. That's not really known exactly how to confidently do that. And so the workshops they saw the drag prediction workshops and said, well, we should do this for high lift and really bring the community together to try to put our brains in one place and get something working better.
And where do you see it from then to now? How have you seen the progression being in terms of accuracy, in terms of capability?
Well, I guess the first 3 workshops were almost all Reynolds average Navier-Stokes. And one of our big conclusions so far has been that Reynolds average Navier-Stokes cannot consistently and accurately predict separated flows. So it cannot consistently and accurately predict the high lift flows. So for a lot of it, it was not much progression other than just confirmation every time that we can't do it, or we have this issue. And then very slowly over the last couple of workshops, we've had more of the scale resolving type of simulations enter into the picture. And we're seeing now the push in that direction, and seeing how it's still not perfect, but those methods still have a lot of, there's so many out there, so many different ways of approaching it. But we see that the flow physics is better captured by those methods. We see the separation patterns and the reasons for the stall that happen near maximum lift are being captured by those methods.
But do you think, therefore, we're close to solving this problem? Where do you see as the...
Well, I think it's certainly closer. In projects, we often have, milestones and points where we declare success, and it's maybe almost too easy to say, yeah, we've solved it, when really it's just made a step in the right direction, and it's certainly getting better, but there's still a ways to go.
I saw you just recently did a paper, which I guess all of this is sort of leading to, isn't it? Which is this certification by analysis. Where do you see that being? And maybe you could explain just this terminology. I guess some people call it digital certification, some people call it certification. How would you explain it, and why is it an important thing for NASA and others.
Yeah, well, it's an important thing, especially for the aircraft industry. I guess NASA is helping to support that goal. But it's the idea that right now, when they design airplanes, there's a lot of wind tunnel and flight tests that are very expensive that take place during the certification process. And the hope is that some aspects of the certification testing could be done by CFD in combination with the others, that would lessen the need for all of the expensive, especially the flight testing, but to reduce the expense of the testing. So to get to that point, though, there has to be extremely high trust in the CFD that what it's doing is as good as the other type of testing. And so that's the hope. At this point, I think it's not there, but that's the idea of push toward that goal.
I think that's the one where I find particularly interesting around machine learning, because I guess if you're going to do, the way I see it, certification by analysis makes sense. Mm-hmm. It takes billions of dollars, years to do a lot of the wind tunnel and flight tests that will still need to be done, but I guess it's just reducing the number of them, such that the ones that they do could maybe be more high fidelity or more detailed. And it seems like scale resolving methods are the sort of methods that could help in that. But then this is where the interest in machine learning comes in, because there's a lot of talk of machine learning, but the issue then is the reproducibility and can you explain it? I guess if you take a scale resolving, you can say it's solving these equations with this numerical scheme. You can there's a theory how you get to the answer, isn't there? Where most people cannot exactly explain how a machine learning model gets to the answer. You know what I mean? Like how
that's right. The computer can't even tell you how it gets there.
So I do kind of wonder whether there's a bit of an opposing challenge here, that machine learning may offer the challenge to do things faster and cheaper, but does it meet the test of being fully explainable and reproducible such that you can use it to do
right?
Because there's a lot of, I think the reason I'm saying this is, how it is, there's always, when it comes to funding, there's buzzwords, isn't there? There's things that attract funding. So for a while, RANDs was it. I think now it's almost the opposite, where if you put RANDs in your funding proposal, this is what a lot of academics tell me. That is a guaranteed way for it not to be funded. Yeah, because they say it's all been done. Yeah. And then it was all about scale resolving. Mm-hmm. And that was the way to get things funded. But it feels like now, if you just say you're doing scale resolving, that's not considered novel enough.
Everyone does it now, yeah.
You say you have to do machine learning, and the sort of concern is if all the money is put into the machine learning for partially good reason, does it actually take money away from perhaps some of the methods that ultimately may need to be used because of this reproduce? Do you see that? Do you see many of the NASA project, or not just NASA, but just projects you're involved in?
Oh, in general, yeah, I think so. It's like buzzword funding. Yeah, you almost have to do that to get funding. And this is one of the concerns about the Turbulence Model Benchmarking Working Group. It's a big mouthful to say. They, that group in general feels that RANDs, because Reynolds average and average Stokes will be around for a long time. It's a very useful and usable method. We shouldn't just fix it in time and stagnate it. There should be continued development. And so it would be nice to have continued funding to some degree, to some level for that effort.
Yeah. I guess this is always the challenge of existing methods versus new methods. You have to sort of keep things going, but if you lose the older methods, it's tricky. I was keen to take a slightly different turn. No, in a positive way. Okay. What's the best conference you've ever been to?
Okay, the best conference I've ever been to. That's not a question I was expecting to get. Well, I've been to so many AIAA conferences, right? I mean, I've been to Reno probably 8 times, maybe 50 AIAA conferences in my life. So it's hard to say if they're. I mean, I always enjoy them, and they're very good. So I have to think of a novel conference that's something out of the ordinary that I've been to. Well, I would have to say probably one of the first workshops I went to in Europe, where this idea for the turbulence model verification came about. That I think that was I always think back fondly on that workshop. First of all, because it was in France.
Okay.
And I hadn't been there before, and they had wine for lunch.
See, there we go.
But I just think fondly on it, just from the fact that was where the idea first came to me for the turbulence modeling website.
Did the wine help the idea of?
I don't think so. No. Yeah.
Do you remember where in France that was?
I think that was in Poitiers.
Oh, okay.
Yeah.
Okay.
Yeah. Where Joan of Arc was tried or burned or something.
Oh,
I don't
wow.
know.
Okay.
It was part of the tour there.
Yeah, I mean, I love the AIAA, but there is something nice. I see the value. The AIAA conferences are fantastic as a networking event to see everybody in one place. It sort of saves you. Everyone's going to be there.
That's right.
To a certain point, but there is a value to sometimes these smaller workshops that have a very targeted focus. And I must admit, I do kind of like these ones. I'm obviously a bit biased being in Europe myself, but there tends to be a sort of a large social aspect to it, which is quite helpful to sort of start ideating ideas.
Yeah, and you meet new people because it's a place you don't ordinarily go, and it's out of your normal wheelhouse. So that's always nice too.
Okay, so maybe we can find the name. It was probably in a COFTAC thing. I think it was, yeah. That reminds me, I've seen some reports. I can try and find it. I can maybe put it in the show comments. Okay, what was the worst conference? The worst location for a conference?
The worst conference. Well, maybe the one that was held here in Norfolk. There was an AIAA held in Norfolk, so it was so close that we just had to drive to and from it.
Oh, you couldn't even stay. You couldn't justify staying.
Couldn't even justify staying. You just had to drive from home. Yeah.
What about? Didn't they used to go? This was before. So, what's the history of Reno? Was it always in Reno? Was that the thing? And someone told me that there was. I
don't know about always, but it was there for many, many years. I think AIAA had a nice deal there. Maybe that was the reason. But it was also a very inexpensive place to stay. I remember $55 a night was the cost of the room for many, many years.
Wow. Okay.
It was just hard to get to. That was the hard part because it was in January. And then, of course, in Reno, depends on the weather, and it was often fogged in. It was one time we had to drive through a snowstorm from San Francisco to get there because the flights weren't going in.
Wow, that's crazy. Yeah, I think one of my favorite conferences, I don't know if they still have this philosophy. I think they did, which was the ETMM, which is the European Turbulence Modeling and I should know what the acronym is. And something measurement, something like that. And someone told me that if you wanted to be an organizer, one of the requirements they had is that ETMM must always be by a beach.
That's right. I think I heard that too. Yeah.
And but it did make it a very nice event to do. So that I think there was one in. I'm not sure if you were there.
Yeah, I went to the one recent. I have never been to any of those, but I went to one recently. I think that was the one near Barcelona. Was that the one?
There was one in Marbella that I think I went to.
Okay.
And, that was one. The only one that I'm jealous of is every time the AIAA seems to have something in Hawaii, which is not very often nowadays.
Right.
I've never been able to make, but I do seem to remember that about 10 years ago, it was in Hawaii, and all the European people I knew were trying to desperately put together abstracts to justify going to Hawaii.
There was a big flack when they first had it in Hawaii. Some of the NASA managers were saying this isn't right, because it's like you're going to a resort. It doesn't, it's
like
not right for a government person to go to a resort. We have to be.
No. Especially whenever there's times of sort of economic crunch, I guess those get more challenging. How about one of the things that I've always keen to do, and I guess part of the reason for even doing this podcast was to help people who are maybe a bit earlier in their careers and are not so clear, sort of, how to progress throughout their career. What would be your advice? And I don't know if you do mentor people or help people in terms of working for NASA. What are the routes? So if you're, let's say, an undergraduate or a school kid in the US, what routes are there to ultimately get to NASA?
Well, part of working for NASA is being lucky, because they don't hire very often, and it's very competitive to get in. But the job itself is great, because there's a certain amount of autonomy. It's probably similar to being in a university to some degree, although maybe a little less pressure from the point of view of having to get funding. Yeah. But I guess the kind of advice I would give would be, to always say, at least when you're young, to always say yes, to anything, and sign up for things and try new things that are challenging, that no one else wants to do, because you'll always learn something from it. And then also, I think, hook on to things that happen by chance, and if you see something that happens by chance, then it's a potential route to follow. Follow it if you can.
But are you aware of, like, even in Langley, do they do internships? Do you, if you're like an undergraduate, can you come over to other those sort of programs? Yeah,
they do have internships. It's an official site. It's changed over the years how they've done it. But there's a internship program where they bring in even high school students, college students, various different levels.
And how does it, I think I know the answer to this, but maybe it's interesting for others to know. So you join at NASA, correct? And am I right in that when you first join, you quite often join as like a contractor almost? Would that be right to say that there's a sort of, do you know what I'm getting at? And
right, yeah.
Could you explain how this?
They have civil servants and they have contractors. Yeah. Now the civil servants are the difficult, the ones that don't open up so often. There aren't often positions, or the positions are very few and far between. So often they'll have contractor positions, and I think even now they've even changed the positions. Maybe not be a lifetime position. They'll be like term hires, as a way of trying to limit the number of total civil servants, yeah. So term hires, which would be, it would be a 5-year position, renewable depending on your,
okay.
How well you do, or the needs for the projects.
I guess this must be very different across NASA, but you mentioned that, and I've always wondered myself, like with a university. So is it essentially that you're sort of treated as your own specialist, where you sort of have a freedom to work on your own projects as well as you're assigned projects to work on? Is that kind of how it is? There's a bit of a blend between the two. There's some independent work and there's some sort of project work.
Yeah. Well, I think the way it optimally works is, 50% of your time is spent reading emails, right? Like everybody nowadays. But among the time when you actually do work, so the projects, when you're first hired, especially, you're given a project and you're expected to work on the project. I think as you become more and more senior, you have more of a say in contributing to what the projects are doing, right? Because projects often get their ideas from the the people that work there. The senior members will help define what the project's goals are. Mm-hmm. But then every individual also is given, I mean, again, this is in theory, given like 15% of their time to do whatever they want. This is a white space type of activity mm-hmm. where they encourage you to go try something that you saw that you didn't, it's not necessarily a project goal, mm-hmm. but something that you think might turn out good and give something. So the problem, of course, is finding that 15% sometimes, yeah. Especially with all the emails.
Yeah, no, I can imagine. Did you ever, there's often a debate, academia, industry, government. Mm-hmm. Were you ever tempted to go to an industry position, to leave NASA?
Yeah, I'd say, throughout my career, I've had several times when I thought, well, I've done this long enough, I should do something different, and thought about, what if I worked at Pixar, or Tesla or something,
yeah,
but never got beyond the point of just kind of thinking about it. But, yeah, and then at one point, some folks have left NASA and worked at universities, and then sometimes they come back, or they've migrated from universities to NASA. It's very different. I mean, we're similar to university. I think there's a lot. There's kind of an academic feel to working at NASA. Very academic environment in general, but we do have very definitive project goals and project thrusts. So therefore, there's milestones and needs, NASA type, thrusts and goals that define you, where you may not have that in a university environment. But then, of course, in a university environment, there's other pressures of trying to get funding from places like NASA.
Yeah,
and then, of course, industry. There's always the worry of the ups and down swings in the industry.
So, what's kept you? Is there a certain thing of? Are you over the NASA thing, or do you have any moments like, I don't know if you ever wear the NASA t-shirt when you go through? Are there any times when you sort of have that moment, you go, oh, actually, this is pretty cool that I work? Is there anything that keeps you basically at NASA like that?
Yeah, I think that there's that factor. There's been a lot of times where you run into people and you say you work at NASA and they all go, ooh, and then you say, well, it's the aeronautical side of NASA, and they say, the what?
I was going to ask you about that.
Yeah, everyone thinks of the space part of it. But I think I've really enjoyed working here. It's been nothing's perfect, and there's always, the grass is greener thoughts. but overall, I'd say it's been a really good place to work.
You said right at the beginning that you attempted to go into art. So have you managed to keep that balance? Do you still draw? Have you managed to sort of keep that hobby alive?
Yes and no. It's gone in cycles like anything. It's energy, right? I mean, if I have, there's been a time in my life when I had a lot of energy, and every night I would do some kind of art project or something just for fun, try to enter in shows. At one point I was a member of Art Alliance from the Hampton Roads area, so I would be constantly going to and from there. But then, you get tired of that, and the cycle out of that, and then everything gets packed up and put on a shelf somewhere, and you don't do much. But
do you think that advice is right, though, about art, a job that pays well and not do art? Because I've heard this a lot, that some people are encouraged away from the arts to go to a safe job like being a doctor or being a thing. Right. I mean, when you look, do you think that was the right choice, or do you know friends and family who have, made a living out of art?
My sister's made a living out of art. She's done very well. She's actually a professor of art up at
oh wow
at a college. Yeah, it's I don't know if that was the right decision or not. I mean, the professor that I trusted, the professor who told me that, and I felt that was the right decision at the time. obviously if I had made a different decision, everything would be, wouldn't have the same family and wouldn't be, so it's right from that perspective that what I did. But yeah, I don't know. It's really hard to go back in time and say.
You've contributed a lot. You've done a huge amount of things. Is there anything that you still feel is unfinished? Is there anything that you're like, I have certain things I really would like to go and do or achieve that I haven't yet done?
No, I don't think so. I mean, when I was younger, I would be, of course, there's always the dream to become another Bram van Leer or, some
surname
Einstein or something.
Yeah.
But that eventually you say, okay, this is what I'm good at. I'm well organized. I can figure out how to do these certain things, and I'll just enjoy what I am able to do as best I can do it. But I'm not going to solve turbulence modeling. That was also a dream too at one point. Like, oh, this model is everyone's gonna use it. It'll be the best thing to come along. But no, it's so just bow out gracefully at some point. Say, oh well, this is.
Yeah, no, it's true, isn't it? It's like almost. That's why I enjoy speaking to people like Florian or Philippe, who are the rare individuals that you could say have done that thing of having a surname after a model. But right. I guess the sad reality is that for most people, that is never the case. And I remember the same thing during my PhD, thinking, oh yeah, well, if I sort of move this equation around, if I can fit this line, maybe this could be a new model, and this could be it. But it's actually much harder than you realize, isn't it? To do
yeah, definitely.
And it's respect to those people. But I don't think, whilst it's amazing what they've done, I think actually what you've done, which not to put what you've done just in one circle, but I think where I genuinely think you've done a lot of help for the community is the curation of knowledge. You can have the best models in the world, you can do the best research, but I don't know if you've consciously focused on this or not, but you've seemed to have done a lot about documenting it. Like when I look at what you've done with the turbulence modeling website, with the high lift, with CGNS, with the codes, like you seem to be very good at documenting and curating that knowledge and almost that public dissemination knowledge. Is that a conscious thing you do, or you've just sort of slipped in to the
probably just slipped in. Yeah. I mean, I saw the need for it maybe and just did it because it seemed like the right thing to do.
But I think kudos to you for that, because genuinely, if I look at all these new methods, these new startups, new methods, they almost all are showing that they've validated their thing against some basic turbulence modeling website case. They've almost all taken some high lift case and running it. And I know it's a team effort, but a lot of that has been basically put on a website, curated, organized by you and a few others. So I would argue, whilst your surname may not be on a particular turbulence model, I think you've still actually I think you can have a tap on the back for contributing.
That's nice of you to say that.
Yeah. And I think others would agree with me too. So I really appreciate you speaking, and I have certainly learned something new. I had no idea about the art connection. I didn't know that maybe you could have been a spy. That's never too late.
Not a good one, though.
No. But yeah, and I hope we can have a good chance to catch up at the high lift workshop, which
coming
will
up.
Be a nice way to sort of. I don't know about you, but after that, I feel like I need to have a break.
I think August will be a good time for. Yeah, this next month is not going to be fun for collecting everything and getting it ready.
Yeah. Brilliant. Thanks, Chris. Really appreciate it.
Sure, Neil. Enjoyed it.
Cheers.